Good morning, friends. Welcome back to the class. I hope you all are safe and happy at your home. So let's have some discussion today about the symmetric and skew symmetric matrix in this session as a session number 4. So before understand the concept symmetric and skew symmetric matrices, first we need to understand the concept transpose of a matrix. What is meant by transpose of a matrix and some fundamental properties of transpose, and then we'll introduce the type of symmetric and skew symmetric matrices. Based on that we are going to prove 4 to 5 theorems, right? 4 to 5 standard results, right? Thereafter we'll discuss 4 to 5 sums to understand the entire concept. Fine. So let's have a discussion on the transpose of matrix first. What is meant by transpose of a matrix? First I will take randomly one matrix A, 2, 3, 4, 5, 6, 7. Now I can write the order of this matrix as 3 rows and 2 columns. 3 rows and 2 columns. So if the rows and columns of a given matrix, if interchanged, so what you will say, right? What you will say if I change the rows and columns, so ultimately the row 1 become the column 1, row 2 become the column 2, row 3 become the column 3. So after interchanging you may observe that order also reverse, 2 rows and 3 columns. So the way I am interchanging the rows and columns, right, is called the transpose. Transpose means interchanging of rows and columns of a given matrix. I repeat, transpose of matrix means interchanging of rows and columns of a given matrix. It means if the order of the given matrix is 3 by 2, its transpose order becomes 2 by 3. So here the transpose of given matrix is represented by writing a capital T over the matrix symbol, or in some cases we are also using the A dash. So A dash or A transpose are the symbol used to represent the transpose of a matrix. Now I can take one more example to understand the transpose of matrix. Now B is a matrix which showing 3 elements, which is called a row matrix because it has only one row. So 1 row, 3 columns. Now I can write the transpose of this matrix. B transpose is simply by entire, take one row, first row wise, take R1 and write in column wise. So R1 become column 1. If I interchange, nothing else to change. So hence the order of this matrix become what? 3 by 1. So 1 by 3 order becomes 3 by 1. Hence it is called what? Transpose of B transpose is nothing but what? Transpose of matrix B. A transpose means transpose of matrix A. So if I do the transpose of transpose again, यानी कि मैं इस मैट्रिक्स का दोबारा ट्रांसपोज करूंगा, it means B transpose the whole transpose. So what I will speak again, this column matrix become again row matrix. It will take the actual matrix. This is B matrix. Means transpose of transpose again a matrix itself. So this has become the first and the most important property of transpose of a matrix. So I hope you have understood the definition of transpose of matrix. I repeat here. Transpose means simply by interchanging the rows and columns of a given matrix. So symbolically what we are speaking here, if A is a matrix represented by Aij of order m by n, then A transpose will be simply by changing the order of the element, hence Aij becomes Aji and the order of the matrix becomes n by m. So this is a common definition of transpose of matrix theoretically. So now we are going to list 4 important properties of transpose of matrix which are very useful to prove standard results further. Okay. Right. So now I am just writing the 4 properties of the matrix C. What is that? Important properties of transpose. Properties of transpose of matrix. The first already we have discussed that A transpose whole transpose is always equal to A matrix itself. Second, K into A, K is any non-zero real number. K times of A whole transpose is always equal to K times of A transpose. Value wise it's same. Remember, K times of A whole transpose is equal to K into A transpose. You may verify this theoretically. You may verify the same with the help of example also. Okay. We are not going to discuss their derivations here. And A plus of B whole transpose is equal to A transpose plus B transpose. I repeat, A plus B whole transpose is equal to A transpose plus B transpose. Similarly, for difference also, A minus B whole transpose is equal to A transpose plus B transpose. The fifth is A into B whole transpose, product. So product will be, it's not like in a sequence, it's in a reverse order. It means it's always equal to B transpose into A transpose if their product is defined. So when I listing this properties of transpose, I never mention the condition on the type of matrix. It means it's not necessary that only in a square matrix it will be possible. If A and B are any general matrices where the addition, subtraction or multiplication is exist, that is the only condition they have to follow. And now if you see this, the last one, AB whole transpose is equal to B transpose into A transpose. So this can be generalized by taking, let us say, the product of 3 matrices I am having. If I want to do the transpose of this, I can simply do the transpose by opening this bracket in a reverse order. It means C transpose into B transpose into A transpose. Remember, so this will be a generalized statement. So you may apply this statement for n number of matrices where the product is exist, multiplication is exist. So these are the most important 5 properties you need to remember to discuss further. Okay, so first one is A transpose whole transpose is A. K times of A whole transpose is equal to K times of A transpose. A plus B whole transpose is equal to A transpose plus B transpose. So to sake of convenience, instead of speaking transpose, transpose and transpose, we are speaking A dash. Dash is also representing transpose. So you may also speak A plus B whole dash is equal to A dash plus B dash. A minus B whole dash is equal to A dash minus B dash. A into B whole dash is equal to B dash into A dash. So these are the 5 important properties of transpose of matrix. With the help of this definition and the properties, we are going to discuss 2 major types of matrix or matrices. The first one is symmetric. What is meant by symmetric? Just like in symmetric, geometrically what we are saying, they are identical on both the side, and through a line of symmetry. In a similar manner, here in matrices also, this property holds true. And what is that? If, remember, this condition means these definitions of symmetric and skew symmetric is only defined if on the given square matrices. So if a matrix A is a matrix of order n by n, or also I can written as A is a matrix defined as A I J, order is n by n, means it's a square matrix. If A is a square matrix such that its transpose is equal to matrix itself, such that it transpose is equal to matrix itself. If a matrix is framed, if a square matrix is framed such a manner that after doing a transpose you are getting the matrix itself, in such cases the given square matrix is known as symmetric. This is what? Symmetric. Are you getting? So I am taking one example how it can be possible given. I am giving a first example for symmetric matrix. I am taking one matrix A of 2 by 2 order, because I need to take square matrix only to define symmetric and skew symmetric. They are only possible when the symmetric and skew symmetric. Otherwise, it will not satisfy the definition, because when you do the transpose, order will reverse. So if I take a general matrix of order 2 by 3, then order become 3 by 2 once we do the transpose. They cannot be equated because their orders are not same. So to equate two matrices, what is the condition to be followed? Their order must be same. And it is only possible to define symmetric and skew symmetric just if the matrix is square matrix. Now I am taking one example. Here 2, 3, 3, 2. So it's a 2 by 2 matrix. Now if I do the transpose of this matrix, what you will say? A transpose. Simply row wise will take and will write column wise, or you may take column wise to write row wise. So I am taking the row 1, I am writing in column 1. I am taking the second row, I am writing second column. You will see both the matrices are identical. Hence, from here I can say A transpose is equal to A, or A dash is equal to A. Hence, this is symmetric matrix. So, you can just remember कि while doing this transpose, you can say the diagonal elements will not change their position. This is a common observation you can observe, that while doing the transpose, the main diagonal elements, principal diagonal elements never changes their position. Rest are or other elements are changing their position. Fine. So now we have understood the definition of symmetric matrix. Now we'll move to understand the skew symmetric matrix. What is skew symmetric matrix? Skew symmetric matrix. It's also defined on the square matrix, where A is a square matrix of order n by n such that A transpose is equal to minus A. Remember, A transpose is equal to minus A. If the matrix, square matrix satisfying this condition is known as skew symmetric matrix. It means I can also speak, it means that therefore I can also say Aij element becomes minus A J I. Order will reversed. A12 element become A21 element. Sign will also change. Remember this. So here Aij is equal to minus Aji, where I and j are the possible values according to the given matrix. So simple skew symmetric means a square matrix satisfying this condition where A transpose equal to minus A. So now I am taking one example to understand how the square matrix can be a skew symmetric matrix. See, I am taking one example, a square matrix of order, let's say 3, 0, 3, minus 2, 0. This is a square matrix of order 2 by 2. If I do the transpose of this matrix, what you will say? If I do the transpose of this matrix, what you will say? It becomes the row 1 becomes the column 1, row 2 becomes the column 2. Am I right? So this is A transpose. And what is minus A? Means minus A means this matrix is multiplied by minus 1. Minus A means the entire matrix is multiplied by the minus 1. Each and every element is multiplied by minus 1. 0 doesn't make any difference here, so it will be remain same. It becomes minus 3 and it becomes 2 and it becomes 0. Correct. Now you can see, is it A transpose equal to A? No. Okay. Just let me change the example here. I took a wrong example. That's why we are not able to get. I'm just changing the one single element. Now see. So this is a square matrix I took where the diagonal elements I kept as 0 and other diagonal elements I kept, numerically they are same, symbolically they are opposite in nature. If I took here 2, so here I took here minus 2. So in this way, if I do A transpose, I will be able to get this, and minus A means this. Now you can compare here, A transpose is equal to minus A. From these two results, I can say A transpose is equal to minus A, which satisfying the condition. Hence, the given matrix, square matrix A is called skew symmetric matrix. I repeat, skew symmetric matrix means a square matrix is said to be a skew symmetric if it satisfying the condition A transpose is equal to minus A, where the every element Aij becomes minus Aji. Means they are reversed, along with that sign will also change. So this is a second type of skew symmetric matrix based on the transpose, concept. So now we have understood symmetric and skew symmetric matrices. So just I am elaborating these two matrices in short in a symbolic form. Let's see. Right. So finally what we have understood, right? The first one is, if a matrix A of the form Aij of order n by n, right, is symmetric, if the square matrix is symmetric, which implies the two results we can say. Transpose of A is equal to A. The first condition, which also implies that Aij is an element becomes Aj element, that is रो एंड कॉलम्स इंटरचेंज हो रहे हैं. सो अल्टीमेटली A12 एलिमेंट क्या बनेगा, A21, उसका पोजीशन इस तरीके से रिवर्स होगा. एंड is skew symmetric right? If a matrix A is symmetric, it follows two conditions. If it is a skew symmetric, it says that transpose of this matrix will equal to minus A as well Aij is also equal to minus Aji, right? So they are interchanging the elements along with the sign. It means that if it is a positive number, it becomes a negative number होगा तो positive. So with the help of this property, we are going to prove one fundamental characteristic property of skew symmetric matrix, which is being asked in boards many a times. Now what is that? Simple. In this condition, where for skew symmetric I am talking about, if I take, if I is equal to j, what is by I is equal to j? They are representing the diagonal elements. Now if I take I is equal to j in this condition, it implies that Aii is equal to minus Aii, which also implies 2Aii equal to 0, which is Aii equal to 0. What does it mean? Aii means either the element representing A11, A22, A33, A44 and so on. It means Aii representing the diagonal elements. So all the diagonal elements will become 0. Okay. If we are talking about what? If the given square matrix is skew symmetric matrix, then its all diagonal elements will be 0. That's why you remember the example which I've taken to prove it is skew symmetric. I kept diagonal element 0 and I took the other diagonal elements in a same order by reversing their sign. So you may give n number of skew symmetric matrix, right, examples just by following this condition. So this is basically a theorem कि they may ask the question, prove that diagonal elements of skew symmetric matrix is always 0. I repeat, prove that diagonal elements of skew symmetric matrix is always 0. Then you need to just start with the definition. Skew symmetric, if a square matrix is skew symmetric, which implies A transpose is equal to minus A, where Aij is equal to minus Aji. If I take I is equal to j, this condition becomes like this, where by simplifying you will say Aii equal to 0. It means that all diagonal elements are 0. Hence proved. You may also give some suitable example here. So if I want to write 3 by 3 skew symmetric matrix, just I am following the same. First, I will keep all diagonal elements of the matrix will be 0. Then I am just going to write the other diagonal elements. If I keep here 2, so diagonally element is here minus 2. If I keep 3 here, so diagonally opposite element will be minus 3. If I keep here 4, so diagonally opposite it is 4. You can see when I say diagonally opposite elements. So this is what A12 element. So A21, its opposite diagonal element. See, this is called diagonal. Apart from the main diagonal, you can see This is the main diagonal element. So main diagonal elements are zeros. Then other opposite diagonal elements are, you can see the change in the elements. If it is a positive number, it will be a negative of same number. Similarly 3, so minus 3, 4, minus 4. If you take here minus 2, it will be plus 2. If it is minus 5, it will be plus 5. If it is 6, it will be minus 6, like this. So this is a characteristic property of skew symmetric matrix. I repeat, here, if it is a skew symmetric matrix, the diagonal elements must be 0. But converse is not always true. It means simply by taking the diagonal elements are 0, you cannot say it is skew symmetric. Example, I am taking here. If I write like this 0, 0, 2, 3, you can see the diagonal elements are 0, but it is not a skew symmetric, because if you observe the other diagonal elements, they are not following that condition key. If it is positive 2, it must be negative 2. Or it is 3, it must be minus 3. So they are not following that. Hence it is not skew symmetric. So here you have understood 3 important points about the skew symmetric matrix. The first point, skew symmetric means they must satisfy 2 conditions. A transpose is equal to minus A, where Aij is equal to minus Aj. Second, all diagonal elements of skew symmetric matrix is always 0. The third point, if the diagonal elements of a square matrix is 0, it need not to be a skew symmetric matrix. It need not to be a skew symmetric matrix. I have given example here. Hope so you have understood the definition of symmetric and skew symmetric. Now, with the help of this definition and the 4 properties, 5 major properties of transpose, we are going to prove important theorems which are there in the syllabus and they are being asked in the board exam frequently. Now let's have a discussion on the important results. What are the important results we have? Right. So here I am writing first here symmetric. So symmetric का definition हो गया A transpose is equal to A. And second one we discussed that skew symmetric. Skew symmetric means A transpose is equal to minus A. That's it. Now 7 points are discussed. Now what are the important results which we are going to prove? The result is, the first result is A plus A transpose is always symmetric. This operation is always a symmetric. This is the first result which we are going to prove. It means if A is a square matrix, then sum of the matrix and its transpose, right, is always a symmetric. So we are going to prove this statement here. Right. Now you know, by addition of 2 matrices, it's again produces a new matrix only. So definitely I can assume this sum as a single matrix, denoted by P. Let us say, let P is equal to their operation. This operation is assumed as A plus A transpose as P. Now to prove, what to prove, where I have to prove that this operation is symmetric, it means that transpose of P must be equal to P. This is my target. Okay. Now, to prove this, I am taking the left hand portion. To prove RHS, I am taking this left hand side, that is P transpose I am taking. P transpose implies that A plus A transpose the whole transpose. But in addition, like the third point here, you can see A plus B whole transpose equal to A transpose B transpose. I can write this as A transpose plus A transpose the whole transpose as the property number 3. But you may also speak A transpose the whole transpose is matrix itself. A dash whole dash is equal to A. Hence, you can also speak this becomes P. So you can say P transpose is equal to P. Therefore, what you can say here? P transpose is equal to P. It implies that A plus A transpose is always symmetric. Have you understood? It's so simple to speak. What I am saying here, A plus A transpose is always symmetric. This operation, this addition is always symmetric. How I have proved? Just by taking this as P matrix. Then I was able to prove P transpose equal to P by taking the transpose of that operation, just by applying the few properties of the transpose, suitable properties, and then I was able to get P. So it means that it is symmetric. Now the second proof. These are standard results basically. Now the difference. We are talking about the difference. A minus A transpose is always skew symmetric. I repeat, A minus A transpose is always skew symmetric. Now how can I prove in the same manner? It's so simple to prove. What I do here, I'll assume this operation as Q. So let Q is equal to A minus A transpose. So what to prove then? क्या हमें prove करना है? We have to prove Q dash is equal to minus Q. Then you can say this operation is Q symmetric. Now I am taking Q dash. Q dash means A minus A transpose the whole dash. Hence A minus B whole dash is equal to A dash minus B dash as property number 4. So I can write it as A dash minus A dash the whole dash, and A dash minus A dash the whole dash is matrix itself as property number 1. Hence it also be written as, by taking minus common, I can write it as A minus A transpose, which is basically equal to Q. A minus A transpose can be written as Q. Now what I have proved, therefore Q transpose is equal to minus Q. Hence, what is Q? This operation. So this operation is always skew symmetric matrix. I repeat, this operation is always skew symmetric matrix. We have proved two important results here. The first one, A plus A dash is always symmetric. A minus A dash is always skew symmetric matrix. Now, the third important result which we are going to prove. Fine. What is that third result here? I am writing the statement here. Every square matrix is expressible or written as the sum of symmetric and skew symmetric carefully read the statement. What does it states? Every square matrix is expressible as a sum of symmetric and skew symmetric. What does it mean? It means that if a square matrix A of order n by n is always expressible as sum of half of A plus A transpose plus half of A minus A transpose, I can write the given square matrix as sum of like this. You can see by taking LCM 2, minus A transpose plus A transpose get cancelled. A plus A is 2A. 2A by 2 means 2 to get cancelled. A. So every square matrix can be written as sum of this and this operation, where this operation will be symmetric, this operation will be skew symmetric. Hence their addition will always give a matrix A. That we are going to prove, this result which we are going to prove. Okay, fine. So I have to prove this one. Basically this I have to prove, this I have to prove. So I will take the right hand side to get LHS. Okay, so what is the right hand portion we have? So I am taking this, I am just solving this. Okay, to prove this, again I have to prove this operation is symmetric, this operation is skew symmetric, as we have proved this is symmetric and this is skew symmetric. Hence I can use the previous results as a standard statements to prove this statement. So I am taking the right hand side. What is that? A plus A dash. I am taking A plus A dash. As we know that A plus A dash operation is always symmetric, right? If it is symmetric, so definitely half of A plus A transpose is also symmetric, as the reason here, K times of A whole transpose is equal to K times of A transpose as property number 2. With the help of property number 2 means when you are multiplying a matrix, addition, subtraction of any matrix is multiplied by non-zero constant, it does not change the property of the matrix. I repeat, if you are multiplying a matrix with a non-zero real number, hence it does not change the property of the given matrix. Hence, if A plus A transpose is always symmetric, then half of A plus A transpose is also symmetric. Similarly, you can also say, similarly, A minus A transpose is always skew symmetric, then it implies that half of A minus A transpose is also skew symmetric. So I have proved here this result is always representing symmetric, this result is always representing skew symmetric. Now just by adding 1 and 2, 1 plus 2, both the results, if I am adding, half of A plus A transpose plus half of A minus A transpose, simply by taking an LCM here, so you will say that A plus A transpose plus A minus A transpose by 2. These two get cancelled. So A plus A is 2A, 2A by 2, which always results into a matrix A. So every square matrix, it shows that every square matrix written as the sum of symmetric and skew symmetric matrices. So this operation is always symmetric, this operation is always skew symmetric, hence their addition will give a matrix A. This is very important result, that by theorem also they are asking in form of question also they are asking these concept in 4 marks. So please remember these questions are asked for 4 marks, long type questions. So here this result is over. Now I am taking the 4th result. Okay, fine. Let's see. So how many results we are deriving? I will sum up at the end. So now I am taking one important results. There these results are asking in the textbook in the form of question. In the form of question here. Let's say I am taking one question here. If I am writing the question over the board as the here we can also speak the result number 4, that if A and B are symmetric matrices, then prove that AB minus BA is a skew symmetric, right? Now see. What is this statement says? If A and B are the symmetric matrices, then prove that this operation is skew symmetric. Now let's take. What does it mean? What is given? What to prove? What is given? What is given? A and B are symmetric. What does it mean? Symmetric means A transpose is equal to A and B transpose is equal to B. This is a given condition. With the help of this, what I have to prove? I have to prove this operation is skew symmetric. It means transpose of this AB minus BA transpose is equal to minus of AB minus BA. Right? Let us say it is P matrix, so P transpose is equal to minus P because we have to prove it as skew symmetric. So I have to prove this. So to prove this, I can take left hand side to simplify to prove right hand side. So I am taking left hand side. What is a left hand side? We have this is. So I am just simplifying LHS, left hand side of this part. So I can apply the property A minus B whole transpose form. So it can be written as A transpose minus B transpose. Correct. But here the product of two matrices whole transpose reversal law ना, इसको हम open करेंगे. It will be B transpose into A transpose. It will be A transpose into B transpose. But as in a question, B transpose is B, A transpose is A. They are symmetric. Hence, I can replace A transpose with A, B transpose with B in the result. It will become BA minus AB. So I can write this as minus of AB minus BA. You can see we obtained the right hand side, hence proved. So simple to prove, very simple to understand. So here we have proved if A and B are the symmetric matrices, AB minus BA result, this result is always skew symmetric matrix with the help of properties of transpose. Fine. Now in a similar manner, the last theorem, or we can also say last result, to prove. Right. What is that? I am writing the question again here. As a question they are asking this. Show that the matrix B dash A into B, this is a result, is a matrix, is symmetric or skew symmetric according as A matrix, capital A matrix is symmetric or skew symmetric. Now see how interesting the question is. What they said, try to understand. We have to show that this matrix is symmetric or skew symmetric according as A symmetric or skew symmetric. यानी यदि A symmetric होगा, so this operation will be symmetric. A यदि skew symmetric होगा, so this operation will be skew symmetric. Means there are two conditions we need to prove by taking first the A as symmetric will prove this operation is symmetric. Second case, where we'll consider A is skew symmetric, then we'll prove this operation is skew symmetric. Let's try. So to prove, first what I am conditioning case 1. In case 1, what I am taking here, A transpose is equal to A, means where I consider A is a symmetric matrix, right? Then I am taking this B dash A B whole. Now I am taking this transpose. So what you will say here, just by rule of multiplication, right, you might also speak dash here in terms of dash. The question is framed. Hence, I can open this with the help of the reversal of transpose. So it will be what? B transpose into A transpose into B transpose whole transpose. But transpose of transpose is matrix itself. So hence B transpose, B dash, A dash into B. But what is A dash? A dash is A. Hence B dash, I can replace this A dash with A into B. So if you see, so I arrived that B dash AB whole dash is equal to B dash AB, the matrix itself, the result itself. Hence it is symmetric. If a given matrix A is symmetric, I was able to prove this is also a symmetry. Now case 2, where we are considering that it is skew symmetric, means A dash is equal to minus A, if A dash is equal to minus A. Now what is the transpose of this operation? B dash A B, इसका ऑपरेशन क्या होगा, इसका ट्रांसपोज क्या होगा? So by reversal of transpose I can write B dash A dash B dash whole dash, which will result into A dash B dash of B is B, but here A dash is minus A, hence I can replace this with minus A into B. So I can write this minus outside the product, because I already told you that when you multiply any matrix here with a non-zero constant, it does not change its property. So I can keep this minus outside. Hence, what I was able to prove here, B dash A B whole dash becomes minus of B dash A B. It follows the definition of skew symmetric, therefore it is what we can say here, skew symmetric. It shows that if a matrix A is symmetric, then this operation is symmetric. A is skew symmetric, then this operation is skew symmetric. This is the question they are asked. Hope so we have understood the concept of standard results here. So I simply listing the important results where we have proved that symmetric and skew symmetric, where you need to remember their derivations because they are asking in the form of questions. Okay, so what are the important results we have proved in this session? Let's have that here. The first one, what we have proved here, the first results, I'm just talking about the results which we are proved. Results, the first one is, if A is skew symmetric, means A dash is equal to minus A, it implies that AII is equal to 0. It means that all diagonal elements of skew symmetric matrix is always 0, the first one. Second one, we have proved that A plus A transpose is always symmetric. It means is dash is equal to A plus A dash only as it is. The third one is A minus A dash whole dash is equal to what we say minus of A minus A dash. The fourth one, we have proved that if A dash is equal to A, B dash is equal to B, it implies that AB minus BA whole dash is equal to minus of AB minus BA, which is skew symmetry. And the last one was, if A dash is equal to A, then what was that? If B dash A B whole dash is equal to B dash A B. If in the same way, if A dash is minus A, this will be equal to minus. So these are the important results we have proved theoretically, and these are the questions they are asking in solved examples. Some are asked in solved example, some are framed in exercise, some are framed in miscellaneous exercise of the NCERT textbook. So by discussing this, we have indirectly discussed 6 sums here. Done. Now we'll take one important questions here, 3 or 4 questions, how the questions they are framing based on this concept, and then we will end up this session. Okay. Now yes, what they are asking. See, wherever it is possible that you can do, so I am not solving. Wherever it is my assistance is required, then only I will solve. I am taking the questions from exercise 3.3. The question number 3. If A dash is equal to 3, 4, minus 1, 2, 0 and 1. Another matrix B is given as minus 1, 1, 2, 2, 1 and 3. These are the two matrices. It is a A dash, you know? So we can do, by transposing this you will get A, by transposing you will get B dash. Now verify that. What they are asking? Verify that. The first part they are asking that A plus B whole dash is equal to A dash plus B dash. Second part, A minus B whole dash is equal to A dash minus B dash. Now see. This says we need to verify. Verify means we need to solve left hand portion and right hand portion. So simply try to understand how can I solve this left hand portion. First I will solve the bracket. What's the bracket says here? A plus B means addition of two matrices. I required A, I required B. B is already there. I required A. How can I get A? Simply by transposing this. So transpose of transpose is again matrix itself, hence मैं इसका transpose करूँगा, so I will be able to get A. इसका transpose करूँगा, I will be able to get B. So means given matrix A and B है, so first मैं यहाँ B transpose find कर रहा हूँ और A find कर रहा हूँ, just by reversing the order, and then I am just substituting the results in the left hand side and the right hand side. I am solving both the sides, then I will be able to prove left hand side result is equal to right hand side, nothing else. I may also add so many parts in the same question. I may also ask to verify that, right, AB whole transpose is equal to B transpose into A transpose. But before asking this question, I must ensure that their product is possible or not. Okay, so simply what they are asking that some one or two matrices will be given to you and they will ask to verify the properties of transpose. You have understood 5 properties we have discussed. They are simply asking that 5 properties to verify. Verify means that property need to be verified as LHS equal to RHS. I hope you will do this part by your own because it's simply a algebra. Okay, let's try yourself this one. Now I am moving to the main important core part of this entire concept, which are been asked for 4 marks. So that I am going to take, that will be the last question of the session. Right. Question is, express the matrix, right, of 2 by 2 square matrix, that is 3 5 1 minus 1 3 5 1 minus 1 as a sum of symmetric and skew symmetric matrix. I repeat, this we have already proved, right, that given square matrix can be expressible as a sum of symmetric and skew symmetric matrix. This question been asked for 4 marks and there are several questions are there in the exercise to practice. Now I am just explaining the methodology to prove this is expressible as sum of symmetric and skew symmetric. First, what I have to show, I am writing what I have to show or what I have to prove. What I have to prove? I have to prove A as half of A plus A dash plus half of A minus A dash. This is what I have to prove. This statement means, so I will take this operation as P and this operation as Q. I am taking this operation as P, this operation as Q. First I will find P value, I will find Q matrix separately. Then I will first prove that P is symmetric, Q is skew symmetric. Then by adding these two results, I will prove the sum is A, that is given matrix. Okay. So what is a procedure here I am following for this? See. To prove this question, we need to follow some algorithm. What is the first step to be followed? First, I will take P, that is, I will find P which is equal to half of A plus A dash. Then I will prove P dash P transpose is equal to P. Then I will take Q, which is equal to half of A minus A dash. Then I will prove Q dash is equal to Q. So after proving this, then I will take the sum P plus Q, right, where I will prove this sum is equal to A. So these are the steps, 5 steps we need to follow. First we'll take the operation P, which is equal to this. Then we'll prove this is symmetric. Then I will take Q, where I will prove Q dash is equal to minus Q, where it is, we can say it is skew symmetric. Then I will add symmetric and skew symmetric parts, that is P plus Q. Then if I able to get A, means the question is derived. So remember this. Now we'll take the question. So this is algorithm need to follow. The first step is P, right? First I will solve for P, half of A plus A dash. What is A? The given matrix. So I am taking that only. A means 3, 5, 1 minus 1 plus A dash, यानी कि transpose of A. Transpose means row wise उठाइए and write in column wise. 3, 5, then second row becomes second column. And simply solve further. So half of 3 plus 3 will be 6, 5 plus 1 is 6, 1 plus 5 is 6, minus 1 is minus 2. Now it is P. So after this, the second step. What is second step? I have to prove now. I am taking P transpose. P transpose means half of 6 minus 2 the transpose. इसका transpose. So ultimately it is half of, by transposing this, row become the column, second row become the second column. It's again a P, you can see. This is P. After doing the transpose also I am getting the same answer. So I can say here P transpose is equal to P. Therefore P is what? P is symmetric. This is a step 1. Here I have done the step 1. I took this as step 1. Step 2 I have proved this is symmetric. Now I am taking step 3, where I am going to solve the operation Q. So I need this result P. I write it. I need this P. Once I write aside, so what I got, P as half of 6 minus 2. Okay. Now I am taking the Q. Right. In step 3, what you will do, first take Q as this operation. First we will solve for Q. How it can be obtained? By writing the matrix A as 3, 5, 1 minus 1 minus A dash means transpose of this matrix, that will be 3, 5, 1 minus 1. And then simply subtract the results. We will get 3 minus 3 as 0, 5, 4, minus 4 and 0. Now we are going to prove that Q dash is equal to minus Q as step 4. Step 4. Q dash means transpose of this matrix is half of, again what? 4 minus 4, 0. इसका transpose हम ले रहे हैं. So ultimately half will remain same. By transposing this, you will see this as 0, 4 minus 0, which can also written as minus half of 0, 4 minus 4, 0, which also written as minus Q. So therefore Q transpose is equal to minus Q, which implies Q is skew symmetric. So I was able to prove P is symmetric, Q is skew symmetric. Now as a last step, I am going to add symmetric operation and skew symmetric operation. So I require the result of Q. That's why I'm just wiping out the steps here. Right. So I have Q as this, P as this. This is Q. This is P. Now this as step 5. What I am going to do is just I am going to add the results. What is P? This is half of 6 minus 2. What is Q? Half of 0, 4 minus 4 and 0. Now by taking half as a common factor, now by taking addition of these two, 6 plus 0 is 0, 6 plus 4 is what? 10, and here 6 minus 4 is 2, minus 2 plus 0 is minus 2. Now by dividing the entire matrix with 2, I will able to get 3, 5, 1, minus 1, which is equal to A. P plus Q is A. Therefore, A can be written as P plus Q. Hence, it is written as sum of the symmetric and skew symmetric matrix. Hence proved. So this is a major important question, 4-mark type question they are asking frequently in the boards. So please do the practice on the exercise 3.3 from the NCERT textbook thoroughly. So we will meet in the next session as session 5 with the concept of invertible matrix, right? So just do the practice and be safe, be happy at your home. Thank you all of you.